Okay, welcome back on our lecture again on repetition and selection. Yep. Ready? I would say today's lecture will be quite important because repetition and selection are two most important program structure for mostly every programming languages. Okay, let's see how. I don't know if you remember this from your, probably not primary school, from your secondary school. So solving quadratic equation. You guys are in engineering, so I hope you still remember this. Okay. Usually the question is to find x. The quadratic equation is x to the power 2, and they will have some coefficient. For example, this coefficient is 5, 3, and 3. But usually, it's in general, you will give you a question like that. So in general, what anyone gives you A, B, C, you want to find the x to satisfy that. After a big chunk of the derivation or proof, you remember this, right? Anyone remember this? That was the formula. That gives you two roots. One is the positive one is the negative one. And the question now is, can we convert into a Python code and a function that can compute that? Okay, so that is the goal first of the problem. And very quickly, this is a code. Okay, I will write a function called solve QE. QE means quadratic equation. And I will have 3 function argument or input, which is ABC, so the user can just call solve QE ABC. And I will calculate. So first of all, what is delta? Delta is when you go back to this equation, this part is delta, right? B squared minus 4AC. And when we write in Python expression, is here, B to power 2 minus 4 times A times Z. Can you write 4AC? Cannot, right? Because it's Python. I cannot just write 4AC, although I'm very tempted to. And then the next is, I need to convert this, right? Negative B plus the square root of D divided by 2A or minus. So I need to do this. I need to compute 2 answers. So those going to appear in your assignment. Then the 2 solutions are the 2 string. And you can call the function like that. So I want to solve QE and my ABC is 1, 5, and 6. Then I can solve that one solution is -2, one is -3. I want to solve the equation 1, 4, 4. Then I know the 2 roots are -2 and -2. Okay, so it's normal. So far it's okay. But here there's something new here that you may or may not know because we talked about it in the tutorial. This one, what is that? In the code, if you see the color carefully, all the functions are in purple, except there's one function called square root, SQRT. Do you see the color? What does that mean? The purple colors function, which is like print and str, are inbuilt function. That means Python just comes with it. You can use it as you want. But for the square root function, is not inbuilt. That means if you just call the square root function, which is SQRT, Python will say, I don't have that function, okay? So what we usually do in our practice in also other language like C or Java, we have a system called libraries. That means if I want to use certain function, I will actually import the library. I don't know how many of you, for guys, play games. You know, play games when you do RPG or whatever, there's a lot of time you do different equipments, right? You go to slaughter people, you bring a lot of weapon. You go for a stealth mission, you want to get as light as possible. Okay, so you want different equipments. And for the library concept is the same. I want to get the certain library to get my function. For example, if you want to draw things, you want to use a turtle function. If you want to do engineering math, you want the NumPy or the Panda libraries. Actually, in Python, we don't call them libraries. In Python, we call them packages. For girls, it's the same. For girls, for example, if I want to go to a ball, a high-class ball, then I dress up with my high-class LV, Chanel, wear my perfume, right? But if the girls want to go for a picnic, then I may wear a hat or bring umbrella, whatever. So different occasion, you will use different function. For example, now, I want to do some math. That's why I want to import some function from math. And you can import other function. For example, if I want to use pi, pi, you know, the 3.1415 something, and I can actually import it from math. I don't need to type it every time. In the math, there's a pi constant, which is not only function you can import a constant. You can import the sine function, the cosine function, they're all in the library. However, the packages or the library are very, very huge, okay? And I'm not going to introduce everything in this course because it's super huge. You can go online, or actually, if you are using idle, the good thing about idle is if you press F1, it's all locally on your computer. Okay, if you press F1, there's a Python doc, all the so-called information are there. And you can click this library reference here, and it will tell you all the libraries, okay? So you can actually, even in your PEs or whatever, you can reference to this library, okay? If you're install idle, okay? And go back to this code. Am I done? Do you think it's a perfect code that I can solve some quadratic equation? Do you remember your secondary school stuff? Can I just solve it like that? No, why? Why? I want to solve 1, -5, 6 is okay. But I want to solve 1, 1, 8. It gives me all the red error message. What's wrong? Yes? Yes, delta less than 0. Okay, good. You guys remember your math from high school, okay? And also, I would like to first point out one thing. When Python gives you these red words, don't be afraid, okay? Actually, the solution to solve your question, your problems, or your issues are actually in the red words. For example, you see the yellow highlights telling you that is that line of code causing you problem. So please read it carefully. Don't be like, it's coding me. No, okay? So just read the red words, try to correct that. And you can see that it's called math domain error. Domain is actually what is its input. That means I cannot do a square root by a negative number. So what should I do? Imagine if you're writing a program to solve quadratic equation for a company, and if the numbers are not right, then your program crash. If you're running a nuclear plant, then the whole nuclear plant have to stop. If you're running an airplane, the airplane have to power down. It's not possible, right? You cannot just crash. So in here, because of this delta here, if you solve this equation, you know the delta is larger than 0. Because b is -5, square b is 25, and so on. So 4 times 6 times 1 becomes 24. 25 minus 24 is 1, so it's positive. It's okay to do square root. But the next one that crash us is b is 1. So 1 square is 1. 1 minus 4 times 8 times 1, which is 42, and then it becomes -31. That means this does not have a solution. Delta is negative. I cannot do square root. Okay, now we figure out that my program cannot handle an equation with negative root, imaginary root. What should I do? Then I need to think of a way. That means inside my program, if the delta is less than 0, I need to do something else. I cannot let it to run into the square root. Okay, so this starting creating what we call branching or division. And is go to our control structure. Control structure is an overall description of how a program runs, especially something called imperative programming. There are basically three. The first one is super simple. It's just called default sequencing. Okay? That is the first control structure. Control structure means how your program is run line by line. The second one is what we are going to talk about in the first half an hour of our lecture, which is called a selection. That means I want to make choice depending on my condition. And the third one is loop. In computer, you always do loop. Why? Human is very bored if you do things repeatedly. Okay, I don't know anyone remember how you practice your dictation, whatever, when you were young, or penmanship. You need to do it again and again, but human don't like it. But we can let the machine to do all our repetition. Okay, so the first control structure is called sequence. It's very simple. Everyone knows about it. Okay, so a program you know that actually is doing line by line. Whatever you do, cooking, you follow the steps, right? Or I don't know anyone try to assemble a not commercial time, IKEA furniture. What do? You follow that line by line, right? Or picture by picture. So there's sequence. So there's nothing really so-called surprising. But for some programming languages, it's not linear. Okay, so some are like parallel or whatever. But this is the first control structure. And the second control structure is making choice. Most of the programming language have this following structure. If something is true, I do A. Otherwise, I do B. It makes sense, right? Real life is like that. If I have more than $1 trillion, what will you do? I will buy a car, eat a lot of buffets, go travel, quit NUS. Okay. Oh, I have $1 trillion. Why do I see? Okay. That is when the condition is true. If I don't, okay, be good and study. Okay. But of course, it's just a fictional scenario. But then it's making a choice that I either do A or do B. But I want you to notice that either do A or do B can be many steps. For example, you can see I do A, I can have many steps. Actually, B, I can do many steps. Okay. B is be good and study and keep a good relationship with a parent in case I run out of money. Okay, you can do that. We have a lot of choices, steps. Of course, you can have nested choices. That means if I am going to have that much money, I can do another nested if then else. If I'm totally heartless, I will do all this enjoyment for myself. Okay, I will buy a car and enjoy myself and go to travel in Europe. But if I'm not heartless, what do? I donate all the money to charity. Okay, you have a big heart for that. Okay, so you can even have a nested loop. For example, this donate money is not in the else one. So you can see, you can actually make choice because of that. Daily life, you make choice lah. Okay, but then just in the programming languages, you want to make it more specifically like this. I just remember there was one hard decision, especially, nowadays, we have those self-drive cars. In the beginning, when we drive cars, right, we have an accident. Let's say, touch wood, we have an accident. We don't know how to react. But now the big challenge of the self-driving car is you can actually pre-program the decision before the accident happens. So the classic example is the 1 guy and 5 guy on 2 track. Anyone know that thought experiment? So if your car, self-driving car, is going to have accident and you either turn left or turn right to avoid. Left is a motorbike with a strong guy. Right is a motorbike with a woman with a child. do you make a decision left or right? So that is hard. So that is a challenge for nowadays if you can pre-program it. But I'm glad that we don't need to do that, okay, at least. But on the other hand, the new challenge for AI car is like that. Become obstacle. Okay, so it's a nested if. The interesting thing about usual conditional statement is I may not even have an else. Okay, it's possible. But you have to have the A, which means always true, always. So if I have that much money, I will do all this. What if I don't? In our programming language, usually we just don't do anything. Continue as your life is go on. Okay? So there's the usual structure for programming language. Let's see how Python did it. So if you refer back to just now that example, let's say I want to solve the quadratic equation, I can do the following. After I computed delta, I will see here. This is the things I'm going to do when delta is larger than 0, which is our previous program, which proceed, try to compute the square root, try to print the answers, and so on. Otherwise, else, I will print, oh, sorry, I cannot compute answer, or your answer is imaginary. Of course, if you want to go more advanced, actually Python have a complex number library or package. You can say, oh, I try to compute a complex solution for you, something I plus something, okay? You can do that. But it's illustrating if the delta is negative or not negative, I can actually make a decision for doing different things. So the usual, what we call syntax is just like that. If there's some expression, remember there's a colon there, okay? It's different from other programming language. Python always have a colon for a new block. And then I do some statement, else I do. For example, this one. I will print, how are you? And ask you what's your age and convert your age into a number. And now, if your age is larger than or equal to 18, you can get a driving license in Singapore. Otherwise, you cannot. Okay? And want you to pay the attention to this. This is the same as the function thing. In Python, when you have an indentation, that means the following printing code is under that if true statement. After the else have a colon, then those are under the false statement. I don't know if my website is still working, but I think it's not working this morning. Oh, it's worked. Okay. Yeah, good. It's still there. So for example, you see this one. It's anyhow cooked, okay? But you can see, you should be able to see the square like that. The blue block is the first level of the if then else. I have this if statement. If age is larger than 10, I will do the green blocks, the green block or box. Else, I do the other one. And then inside the blue box, I have another if then else. So for this one, I need you to know how to visualize this by yourself for all the if then else statement. You can actually, this one, you can do this. Yeah, you can string it and so remember the indentations matters. Don't indent too much, don't indent too less. Of course, just now I said, you can actually have an selection statement without the else. So what will this code print? This code will print nothing because your age is not. If your age is less than 18, then it will print nothing. Okay, but if your age is more than 18, then it will print that you can get a driving license. Yeah. So if your age is less than 18, then you will print nothing. Of course, you can have a nested loop. For example, after asking you if your age is more than 18, I want to ask, do you have a car? You can answer yes or no, okay, Y or N. If it's Y, it means yes, then I say, oh, you can actually drive now because you have a car and you have a driving license, okay? Otherwise, too bad, you still doing nothing if you don't have a car. For example, if my age is 21, and then go to the next statement, do you have a car? Sorry, I don't have a car. You cannot drive now, okay? Because you don't, it's not because you don't have a driving license, but because you don't have a car. Okay. One thing is the previous example here, the nested inner if is and the true block. That means it will happen when your condition is true. And of course, you can put your if then else statement in the else block also. What is this example? Because I know anyone from US here? No, no one from the state. Hey, it's strange. Sometimes it's have some exchange student, okay? You know in Singapore, you cannot get a driving license until you're 18. But in US, it's not. US, I think you can get a driving license when you are 16. Okay? So if you are not 18 years old, that means I'm less than 18 years old, you can still ask, are you in US? If in US is true, then you can actually still try to get the driving license. Of course, you need to over 16 now. But what my point I want to illustrate is here. This else and then if is very clumsy, not good looking. And Python has a way to make it simpler. You can fuse this else and if together. So Python can do this. I don't have any. Python, do you see this keyword called elif? ELIF. That is equivalent to else if. So for example, my code is like this now. If my age is larger than 18, of course you can drive. Elif, if you're in US, then you can still get a driving license. Otherwise, you cannot, okay? So you can actually do this elif instead of elif. What is the benefit? The benefit is when you compare to the previous code, you can see the last if you have to indent. If you have a lot of elif, because you have actually can have a more choices, you need to go all the indentation to the right. But this code will keep all your indentation on the left. You can have more than one elif because sometimes you do have a lot of choice. For example, if you are doing a menu, you want to go to copy them. Okay, if the user input is 1, is ordering copy O. If the choice is 2, is ordering copy C. Choice is 3, is ordering copy O croissant or whatever. You know the Singapore coffee system, right? You can have all these elifs. Then you can actually have a long choice. And without elif, you have to do indentation all the way to the right. But now, good, you don't have that indentation and even visually looks more pleasant. Okay, and actually the elif is something like this. Okay, so you do one, and can you tell me what is the output of this code? A is equal to 4. Also, the other thing is you will try all the condition from top to bottom. First, you will try, is it yes? If A is less than 0, no, it's false. So I go to the next elif. Is A equal to 0? Too bad. A is equal to 4, right? No. So go to the next one. So is A equal to 4? Good. So that is the correct choice. That's why this code will print R. Okay. If every of the elif fail, then we go to the else. Then we'll just print okay. So this one will be R. Okay. Let's see if you understand it. And I would like to ask you to get your phone or whatsoever to try this quiz together. Clear response, if there's any. Okay, this is the code. Yeah, I will give about 1 minute, everybody to scan. Don't worry, it's not graded, so feel free to try. But if you're fast enough, you go to the top of the rank. Yesterday, have somebody go to the top of the rank, like getting all 1,000 points, okay? Uh, for the name, you can enter your name, but don't enter anything offensive, okay? Just a reminder. Okay, anyone need more time? Okay, let's start. Anyone need more time? Scanning. Okay, are you ready? It's also a timed one. If you answer faster, you get more points, okay? So let's try. Start. What will the following code print? It should also display in your phone also, I guess. 20 seconds you have. Is it too long? Okay, let's see. Good. Who is the one a bit fat? Probably is a mistype, okay? So this one is quite obvious because your weight is 70, and if my weight is larger than 40, then it's a bit fat. Okay, so that means you're okay. Good. Ready for the next one? Good, good. Hey, all the girls. Guys, keep up. I think it's a girl, right? Sherming should be a girl. Okay. Guys. Yeah, being okay, next question. Okay. This one also easy, right? Yeah, most of you got that. Okay. Because you win nothing, yeah, you cannot tell 70 or 400 which one is bigger, right? Okay. Those two are warm up, okay? Alicia, I don't know who is Alicia. Let's figure out who is in. Okay. Ready? Let's get serious now, okay? What is the output of this code? Okay, let's see. Aha. Aha, aha. Why? 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 Mark is 80 watt. Why? Can someone explain why? Why is this supernatural phenomenon? Why? The condition is tested one by one from top to bottom. So it's sequential. So you try my mark at 91st, which is fourth. Then the next thing we're going to try is my mark is larger than 70, in which is true. And when we execute B, print B, I finish the decision. Okay? So that is the sequential so-called decision making. Even you have a better choice later, too bad. You already made the first choice. It's just like marriage. You met a suitable person, you think is good, you get married. And that's it. Even though there's even a better one later, you better stick with the original one, okay? That's called marriage. Okay. And okay, hands in, good job. And last one, this one you need to focus. This one actually, I think it's very difficult to finish in 20 seconds. I want to write a code that I give you three numbers, A, B, and C, and I want to find the maximum of A, B, and C. That means after I input A, B, and C, I want to print the maximum of A, B, and C, which is, for example, if 1, 3, 2, I will print 3, okay? So if my code is like that, what should be the blanks? Okay. Drums rolling. Wow, not bad. 60% of you guys got it correct. Okay. Not bad, not bad, not bad, not bad, not bad at all. And I will say if you don't get it correct, probably it's because you don't have enough time, okay? I think because I have a technical problem, I don't know how to adjust different question in different poll everywhere. It's different timing, okay? So I just set everything to be 20 seconds. Otherwise, the first two warm-up questions will be 1 minute for you. Okay, so the answer is, you can actually tell from the inner one first. For example, between B and C, what will you choose? Of course, if B bigger than C, you print B. If otherwise, you print C, right? So the last choice is very naturally B bigger than C. Oh, they are all the same. How about this one? Of course, this should be if A bigger than C, you print A. Otherwise, you print C, right? So the question will be either this one or this one. But of course, this one you select A, and that's why more naturally is A larger than B, okay? And two things, this last question already, so you can relax already. And also would like you to know our midterm is like that. Our final is like that. But don't worry, our midterm and final, usually our clock is one and a half minute to 2 minutes a question. So not to 20 seconds, okay? So don't worry about that. In your midterm, usually our gearing of our midterm question is 1 minute to 2 minutes or 1 minute 30 seconds, something like that. So you should have more time about this. And let's see who is the winner. Yay, Alicia, where are you? Who is Alicia? Okay, later you confess, okay? Yeah, good job, good job, good job. Okay, so I hope it's okay. About this one, go back to this one first. This one, I want you to notice that this one, okay? This is actually trying different so-called entrance. It will be something like this. So before we end this session, I'll let you to watch this. This is a typical if then else. So you tried it if this case, bằng nhau. So you try the next case, bằng nhau. And the L if, okay, try again. Bằng nhau. Finally, yeah, you can have the else. Okay. Okay. So of course, if some of the windows is open, you enter there lah. Okay. You guys are enjoying this. Okay. Yeah. So that's our first part of our lecture about if then else. I will pause for about 5 minutes. We can continue. Okay. So if there's any question, please ask in the poll level where. Share. So for those people who didn't watch this movie, it's called 21, okay? I just talk about the Monty Hall problem. We'll talk about it at the last of the lecture. But if you really want, please go and watch it. It's a very interesting story. It's a real story. Talking about a real MIT professor lead a group of research students to beat the casino system by mathematics. Its winning per hour is $600 20 years ago. It's not those tricks. You don't think about those Hong Kong movie, the gambling one, right? The one you get out a card and then you blow it, it becomes another card. Not like that. It's really didn't cheat in any way. Just use math to beat the system. And they're having a revenue of 1 hour, $600 US. Okay, so go and watch the movie. If you want to read the novel, it's called Bring Down the House. Okay, but the movie is called 21, and you have this handsome guy. Let's continue on our lecture about the repetition. Just now, for the quiz, if you get the first one right, I would say probably you can get a C, whatever, in this course because you know how to do the normal, simple if then else. But if you get the question 3 right just now, I would say you can get a B, whatever, because you can already manage how to do some complicated conditional statement. If you are very fast and get the last question right, I will say congratulations, you may probably get an A, okay? But of course, it's not a guarantee, okay? But that is because you can get the logic very, very precisely with complicated scenario. And before we go on, this is not the ultimate goal. There's still a lot of condition. What are other conditions that will crash this code? Other than delta less than 0, what is the other condition you can crash this code? Huh? Yeah, for example, A is 0. What happens if A is 0? It division by 0 and some other thing, okay? So I think that's your homework later. You try to figure out all the conditions. And that is the first section about conditional statement. And let's talk about repetition. What is repetition? Repetition is like your mom, right? Make your bed, make your bed, make your bed, make your bed, make your bed. Drink water, drink water, drink water, drink water. Okay, so it's repetition, right? I think you guys all know, right? Repetition is what you tell the computer to repeat doing things, and computer is good at that because they don't get sian. They can do 1 million times without complaining, and human does not. So remember, we do this game about repetition. On the Pringles, you play a proof, right? On lecture number 1, and here we talk about that inside the game. When you have one customer, depending on what the customer get, 1, 2, or 3, you will get that and give prizes. But you are not only doing one customer, so you have to repeat the process for different customers, right? So there's a repetition. And do you repeat forever? No, you stop at some place. Maybe the sun goes down, maybe no customer, maybe your prices went out, okay? So there's some condition you will stop running. And usually we have very simple iteration. And I would say this one, a lot of first-time students will confuse with if then else. It's too much like if then else. Okay, let's see. Usually it's while a condition. Hey, does it look like the if then else very much? Just now we say, right? If a condition, you do something. But now is while a condition, I do something. But what is the difference? You can, the first round can treat it as like if then else. For example, while I'm hungry, hungry is a condition. You go and check whether you're hungry or not. If you're hungry, you eat a bun. But if you are simply previous if then else statement, what do you do after you ate the bun? You continue the whatever afterwards, right? But for while loop or a repeated loop, what you did is after you ate a bun, you go repeat and check whether you're hungry again. This loop can be many times as you want. Okay, so you go to check when I'm hungry. If I'm still hungry, I eat a bun. Check again. So you end up with eating 10 buns if you're still hungry. Okay, well, of course, real life may not be possible, but you will just keep repeating until certain condition is satisfied. Of course, you can do nested loops, right? With while I still have money in the bank, I get out the money, and while I still have money in the wallet, I go and spend them. Okay, I keep spending them. And then I have this while loop. So after I don't have money in my wallet, I will finish the inner loop. and then I go to the outer loop and see whether I still have money in bank, and I get out and can restart everything again. Okay, you can have nested loop. And we call this in computer science about repetition is iterations. That means I try to repeat a process until some condition is satisfied. And about this repetition, I will try to divide it into 3 types, because I will say these 3 types of loops can cover up, I would say, at least 95 or 99% of all loops you are going to use, okay? The first one is called, you exactly know how many times you want to loop. But when you know it is when you enter the loop, we'll talk about that later. So, but the next 2 types is you may not know how many times. Let's see the first type first. Remember, we have this Christmas tree in our lecture 2, right? At that time, we do this function abstraction to abstract the 3 lines of code into print triangles and make the whole code nicer to look at, because I see 4 lines of print triangle. But still, I would say actually it's still not a good practice, because what if I want to get a Christmas tree of 10 layers? Then you need to do 10, okay? But you also know that it's going to repeat 4 times here. I know I will repeat 4 times. I want a 4 times Christmas tree. So instead of copy and paste, remember what I said in lecture 2? In computer science, when you're coding, when you do copy and paste, 99% of the time you're doing the wrong thing. You don't want to do this redundancy in your code. Okay, so whenever you copy or the 2 parts of the code is very much the same, you don't want to do that. Instead, ta-da! Okay, I will explain the syntax later, but this code means I'm going to repeat the draw triangle 4 times instead of printing 4 times there. Okay, so it's structure change, and you can easily change it 10 times, 100 times with just changing the number 4. So it's called for loop. And this is the usual for loop structure for a variable I in a range of something, and you do some procedure. This is a simple one. So for I is a variable, okay? Later I will explain about that. I is a variable, and I will be in range from 0 to 5. What does it mean? I will be starting from 0. And then the next will do the print statement, which means I execute the body, and will repeat. When you repeat, I will jump automatically. So this code will print something like this. Okay, I is starting from 0. So that's why I print the first line. Here we print 0. And finish 1 round, go back to the first line, 4. For I in range. Now I finish 0. That's why I will do 1. The next line of code will print. For here I print 1, and so on. Okay? So for I in range n to m, it means n is the start, m is the stop. But wait a minute, why don't I stop at 5? I thought I said range 0 to 5. Why don't I stop at 5? Remember the string slicing last time? It's the same rule. Remember string slicing? String slicing from 0:2, right? I will say from 0 to 2, but excluding 2. So this is the same. Now I'm saying that from 0 to 5, but excluding 5. So that's why it's 0, 1, 2, 3, 4, stop. Excluding 5. And the easy thing you can see that is actually the number of times you repeat is exactly equal to the difference between the 2 numbers. The 2 number is 0, 4, and 4, right? 4 minus 0 is 4. Because you can actually change the start and stop. So that means I know that this will be repeating 4 times. Because 4 times 4 minus 0 is. And then, okay. Yeah, so remember, when you say range from 0 to 5, the 5 is exclusive. Let's try to use it as practice. I hope everyone remember what is factorial, okay? Factorial n means I want to multiply 1 times 2 times 3 times 4 all the way to n. So factorial 4 is 1 times 2 times 3 times 4, which is equal to 24, okay? If I give you a paper and pencil, how do you do it? Now everybody compute factorial 10. How do you do it? Punch calculator, right? No, I cannot. I don't let you to punch calculator. I want to give you a paper and pencil without the computer or your phone, whatever. How do you do it? Because I need to multiply 1, 2, 3, 4, right? Of course, the first thing I multiply 1 now. 1 times 1 is 1, okay? And look at this animation carefully. 1 times 1. Oh, already, okay? And the next one is 1 times 2. And I store 2 is called the temporary product. Next step, 2 times 3 equals 6. The next step, 6 times 1, 4, right? Next, 5, and so on, right? Do you see that the product actually is storing what is the product so far? And I just look through everything, then I can finally, whatever in the product is the factorial one. And this is also just indicated in your program. You only need these two variables. One is product, one is counter. What is the counter behavior? The counter behavior is will jump, right? 1, 2, 3, 4, 5, 6 until it jump to n. So let's convert it into a code. Starting, before we do Python, we write the pseudocode first. Before we start, I will assume product is 1 and the counter is 1. And I will repeat the following. Every time, I will multiply the current product with the counter and replace it with the current product. That's what happening in just now, the animation, right? I use the product, for example, at that time is already 6. 6 times 4 become 24, but I replace the product to be 24 for the next 5 to use. And next, I just need to increase my counter, and that's it. After you repeat the counters, you know the final product will be your factorial. So you just have to, this is the part of iteration. So if you really want to write a code, you can use a for loop. Do product is equal to 1, and for counter in range 2 to n plus 1. This is the multiplication and return product. Any question? No? Then I ask you a question. Why do I start with 2? Why is it not 1? Does that matter? Why? Why it doesn't matter? Yeah, if you start with 1, you just multiply once more, right? But why don't I start with 0? Why don't I do 0 to n plus 1? Sorry? 0 is what? Sorry. Yeah, because the first round, the product multiplies 0 becomes 0, and anything afterward will be 0. Why is it n plus 1? I mean, the n is n plus 1. Why is it not n? Yes. Why? The final one is not inclusive. So n plus 1 is not inclusive. If I only multiply the range from 0 to n, I will only reach n minus 1 without n. So I'm actually only computing n minus 1 factorial instead of n factorial, okay? Very good. And why don't I need to increase counter? Just now the pseudocode, remember, I need to increase counter here. Here, right? I increase counter. Why don't I need to increase counter here in the for loop? Thank you. It automatically increases in the loop. In the for loop, there's a for loop structure. If you use a for loop for I, whatever that variable, you can actually change it to other things. You can change it to chain, you can change it to counter, whatever. That variable will be increasing in your range each time for that. Okay. Yeah, for example, you compute factorial 6. First, the product is 1 and the counter is 2. So you multiply 1, 2, it will be 2. The next round, the counter becomes 3. 3 times 2 becomes 6. The next time the counter is 4, it becomes 24. The next time counter is whatever. Okay, so that is how it compute. So I would like to see whether you can try to cook it yourself. Okay. So the basic syntax for the for loop is for a variable. Okay, the variable can be any normal variable you want, and this variable will change during your for loop. And one small trick is not a trick lah. Sometimes, for example, if I just want to repeat it without referring to what is the index, sometimes people lazy will just put an underscore. Okay, there's a lazy one for underscore in whatever, but it's up to you. Okay, and then the sequence is actually not only about range. Range is just a starter because we haven't learned any other sequences like list or tuple, whatever. Actually, you can do that, but let's stick with the range first now. Of course, you do the body. But for the range, if you remember the string slicing, it's the same thing. You can do the start-stop step. And you can also omit the start, okay? Let's see. Of course, you have the body. You can omit the start. For example, if I say I in range n, I think it's running out back, is it? I in range 10, what does that mean? It is actually equivalent to I in range 0, 10. Because if you just say 10, I will default thinking that the start is 0. Okay, it's a lazy just notation. So this one will print 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And of course, you can start anything to anything. So what will it print? You start from 6, 7, 8, 9, and nothing. Okay, so you cannot continue. So this one will print 6, 7, 8, 9. You can put step 3 to 10, step 4. So try. How many numbers will we print? You start from 3. I print 3 first. And the next number? 7, right? So I print 3 and 7. And the next number should be 11. But 11 is already out of range. So I don't print 11. So this one I print 3 and 7. Okay. So you can use this loop to construct different range. Let's try to put it in use. Okay. The first one is I want to, usually you repeat things for experiment. Usually we make decisions by flipping a coin, right? We assume flipping a coin, the probability of head and tail is 0.5 and 0.5. Is that true? How can you know it's true? Prove it to me it's true. How do I know that your coin is not biased? Did you ever measure the coin that the left side or the right side or the center of gravity of the coin is in the center what? Do you do such things? Do you notice that your coin, the head one seems like more metal than the tail one? Because usually have a head there and more fat, whatever. Or the other way around. How can you be sure about that? Of course, if you just flip a coin, probably in a soccer game, it does not matter a lot. But if it involves $1 million in the casino, the dice you're throwing, the dice, the 6-sided dice, how can you be sure every of the side is having a same probability? Anyone watch also another those Hong Kong gambling movie, right? There's some way you can construct the dice, maybe insert some mercury, whatever. You can actually control the dice to throw the number you want. Or there's some guys have this very magic hand, have a skill that can throw whatever you want. I'm not talking about those who like rotate and then make the dice become powder. Not that one, okay? But then How can I make sure if a random throw the dice will give you 1 to 6 in equal probability? Why? Because that's important. Because the bet on the table is equal probability. And one more serious issue. All the instrument in casino, you should have that, like the Rolex. Every number should have the same probability. But wait a minute, those are physical ones. How about, nowadays, a lot of casino convert the thing into digital. Like the slot machine is a digital machine. And then how do I know that the random generator below is what I supposed to be? Because I will make decision because of that, right? If my math is good. And I don't know, the other one, how many of you play those phone game that you draw card, whatever? You pay money to draw certain powerful character or card, right? Like what, Genshin or whatever, You need to pay money to draw, and then they will tell you a probability, right? Because it's the new Apple rule. The new Apple rule is like, I think it's like 1%. If it's 1%, the probability have to be 1%. How can you be sure that is right? So if you involve money, you need to make sure. For example, go back to our question. If you involve money, let's say today I'm going to gamble with you, bet on $1 billion. If I flip head, is yours. If I flip tail, then it's very serious. I need to make sure my probability is right. How can I prove that? How can I prove that? How am I going to prove that? Well, the usual way is you flip many times. Okay? I will flip the coins 1 billion times, whatever, to test it. And it's true. I was actually in a so-called a credential committee in Singapore. They actually invite some of our professors to prove that the casino system is right. But it's a very hard job. I don't want to do anymore. And no money anyway. But then you need somebody to prove that our casino is actually doing the right job, not cheating people. Yeah, because otherwise, if unfair. So the most very easy way to do, yeah, of course. One way is you can do very cheap math, whatever, to prove the formula that generate the number, whatever is right or not. But the most simple and practical way is I just do experiment. I flip the coin 1,000 times. If I flip the coin 1,000 times, how many times will I get the heads? About 500. You cannot do exactly 500. If the case is you flip a coin 1,000 times, you exactly get 500 heads every time, is also not fair. Why? Because after flipping 999 times, you know what is the last number. After you flip 999 times, there will be 500 of tails and 499 of head, and you know the next number is head or tail. Okay? It's around that. So let's do a code on that. So I can actually simply write a code to simulate that. Okay, so what is it? I try to flip the column 100 times. And this one is I randomly will generate a number, an integer. This is a package from the random package. So if you want some random number, you can get it from that. And what I did is I want a random integer. In the random package, you can generate random real numbers, which is decimal places. If I generate random integers, I will generate any numbers from 1 to 0. I run it 1,000 times. If it's heads, I plus 1, okay? So this one I did have the yesterday. Flip. Yeah, so this is a simplified code. I didn't have a print. I will initiate head is equal to 0. This one I even flip 1 million times. And I will generate the number from 0 to 1. So if it's 1, I think it's a head. If 0 is tail. When I run it, I will tell you. So you see, after flipping 1 million times, I about agar have about 500K of heads. But this number cannot be fixed. Sometimes it's smaller, sometimes it's bigger. We'll run again. Yeah, we'll run again. How come I cannot get less? Yeah, get less. Okay, sometimes it's more than 500K, sometimes it's less. You can even run it 1,000 million times, okay? But I think 1 million times will be good enough. So what I try to say is you can actually use experiment instead of proving your math is right. And it's good because we know that how many times you want to run, right? This one is 1,000 times or 1 million times. But not always you know how many times you want to run. Okay, sometimes you don't. Why? I actually can try to repeat until certain condition is done. Okay. For example, here, what does this cook do? Asking for proposal or forcing a girl to marry you? The cook asks, will you marry me? And then if the answer is not yes, what happened? You ask again. If the answer is not yes, what happened? You ask again. Until the answer is yes, then yes. So good, my girl want to marry, okay? So it will keep looping until one condition, which is answer is not yes, is being broken. And you don't know how many times, okay? But of course, this code is not perfect. I think thanks for Prof. Stevenson. And what if the answer is capital yes instead of small yes? Sorry, I need your more formal answer. Please give me the yes I want, okay? But of course, it's just a small glitch, but I just want to symbolize this while loop is another form that I can actually loop until a certain condition is true instead of fixing a certain numbers. What does this go to? We will, wow, keep pretty R, right? This code, I want to demonstrate one thing. Usually we won't do this, which means mostly the while condition, you are supposed to have freedom to change during the loop. So usually not while false or while true, because you have to make sure the condition may change during the loop until you're doing some forever system or your algorithm is trying to loop forever and then break, okay? And the other one, let's see. What does it bring? What does it bring? How many numbers does it bring? 0. Why? It doesn't print 0. It means it doesn't print anything. Why? Because before you enter the while loop, the condition is already false. So it's like if then else statement in this time, the condition is false, you won't even enter the body of the while loop. Okay, so here I illustrate 2 points is when you want to do some repetition, there are 2 points. First, make sure your loops will change some condition and escape sometime. Second, try to figure out if your loop is being entered. Of course, sometimes you may even have a chance you don't need to enter the loop, but usually make sure whether you enter or not. Okay, so there's a condition. A programmer walked out the room and his wife said, while you are out, buy some milk. And he never came back. Why? Because he's a programmer. The condition is while I'm out. Because I'm out, you can see this crazy guy keep buying milk. Because the condition is while you're out, okay? So be careful of the condition. Of course, our real people know that, okay? But because it's a programmer, while it's out, the condition is true, I buy milk. And then I check the condition, while I'm out, I buy milk, okay? So this is how the programming, the computer works, okay? And of course, you can use the while loop to do the factorial just now we did. But this time, because it's not a for loop, you have to increment the counter. And what is the while condition? I will loop until my counter is larger than n. So here, I will loop, keep you in the loop whenever the counter is still less than or equal to n. So the product will be 1, 1, the counter will increase until the counter is larger than that, you actually escape the loop. Okay. And one thing is, I think is tricky, and this one actually requires some experience. What is the last condition? Okay, so the birdie said, while I'm not having an edge in front, I will keep running. The wolf says, while I'm not on the edge, I keep running. And that's why the wolf run out of that. I just want to say this one is usually the problem of doing while loop. Usually the first loop is fine, but when is the time you escape the loop? I is equal to 1, 2, 3, 4, 5 is like, oh, okay. So think of why is the time you actually escape the loop. And for example, just now the factorial, should I put less than equal to? Should I put less 1? Should I put less than n minus 1? Should I put less than equal to n plus 1? Which one? Okay. So of course, the best way is, wow, your mind is very clear. I actually figure out all the logic and understand this good, okay? But sometimes you just need to do a bit try and error. Okay, so sometimes that is true, but I don't encourage that. But sometimes you need to do some try and error. At least on the other hand, maybe you think very clearly, but you actually make a mistake during your thoughts. So one thing important we talk about next week or also on, you need to debug. You need to make sure your code works by running, testing it, okay? So, yeah. And of course, you can do nested while. That is what we demonstrate in the beginning. For example, this code will print something like a Christmas tree, okay? The most inner while will print this small triangle, and I will actually print 5 times of the nested triangle. Okay, but one thing is, most of the time, if you do a while and there's a counter in increasing, you can still use while. I would suggest if that is the case, you better use a for loop. Okay, if you use a while, you know how many times you increase the counter and you match how many times you use while. You can still use while, but for loop is more convenient for you. So I think sometimes, some case, you can only use while loop. Sometimes you can only use for loop. Sometimes you can use both, but sometimes you only want to use while loop and so on. Okay, so that one is some experience. Yeah, there's a second one. You can run loop anytime. But the third one is quite interesting. What do you mean by oh, sorry. Before we do that, that's why the terminating condition is important. The yellow part is true. That will keep you in the loop. When will you break out the loop? When the yellow condition is being broken. Okay? When the loop is being broken, then you get out of loop. Spoiler. Anyone watch the movie Doctor Strange? The first one? No. How many have watched it? How many haven't watched it? How many haven't watched it and don't want me to do a spoiler? Okay, good. I got your consent. If you don't want to, the spoiler, cover your ears, okay? Remember what Doctor Strange did to beat his final villain at the end of the first one? He got a time stone. And this Valiant monster is super duper powerful. When Doctor Strange just comes, and then kill Doctor Strange right away. How did Doctor Strange beat him? He trapped this guy into the loop. When he's being killed, the time is being reset and repeat. And then he keeps coming, say, I come to bargain. And come to bargain after many, many times until the monster agree, okay, I'm not going to hurt you or invade your earth, whatever anymore. Then he break the loops. Okay? So what is the condition keeping the monster in the loop? Is when this monster answer is not yes. It doesn't agree. Okay, so you have to put that into the while loop. While the monster doesn't agree, keep looping. I come to bargain. When you break that, that means breaks the rules of the monster doesn't agree. That means the monster agree, then you break the loops. Okay, so you have to think very careful about the while loop. Sometimes people will think the reverse. I break the loop condition is putting that instead. Last time. Sometimes you run this certain loop is you run n times, but you can break any time in before. How do you check if a number is prime or not? I assume you know what's a prime number. For example, if I give you paper and pencil, how do you tell if 91 is prime number or not? Well, the normal thing you do is, other than punching the computer or look it up on Google, you check if 91 is divisible by 2, and then you check if 91 is divisible by 3, and then so on, right? Until if it's divisible by 90. 91 is definitely divisible by 91, so you don't need to check. Okay? Very simple. How do you write the program? If all not divisible, then 91 is a prime. Otherwise, so for any numbers, I can just do this. So the program say, I will assume there's nothing divisible. Then I will loop through all the numbers from 2 to 90. And if any numbers, I try to do this n% I is equal to 0. What does this line mean? Someone can tell me? What is n% I equal to 0? Anyone? Yes? The remainder of n divided by I is equal to 0. Can you say more layman English? It just means if n is divisible by I, right? If n is divisible by y, then I will set the variable divisible is true because sum is divisible, okay? And then after I finish all the number 2 to 90, or if it's number n is 2 to n minus 1, then if all pass, then it's okay. Okay, so this code works. However, this is a clumsy code. First, this is the thing I need you to do, okay? In the whole course, a lot of us will do this. The code runs, I submit, I want to forget about it. No, after the code is done, you need to think about how to refine your code. For example, this piece of code is very clumsy. I can directly replace the yellow box by the line only return not divisible. Why? Because if divisible is true, you return false. If divisible is false, you return true. Is it okay? Again, if the variable divisible by sum is true, you return false. If it's false, you return true. That means I just need to return an opposite answer of divisible by sum. So I can actually change this yellow box to like that, okay? And then this one. After I figure out some numbers is divisible, do I need to go through all the rest of the number? For example, if I want to check if the number 100 is a prime number, I check 2. Hey, check is already divisible. Do I need to check the number 3, 4, 5, 6? But then the for loop don't let me to do it. How? I can abort and escape. Ta-da, here. I can directly say if some number is divisible, return. What does return do? In the tutorial we mentioned, right? Return will totally stop the whole program and go out and give you the outcome which is false. So the loop will not go on, and anything in is like abort, abort loop. So I don't need to go through the rest of the numbers. Okay. And finally, wait a minute. Then what does this divisible by sum do? I don't need that variable, right? I can directly say it's return true. Okay. It's a lot shorter code and similar code. But is it the ultimate code? Is it the ultimate code? Can you do better? Can you do better? What if I want to check a prime number which is 10 millions? Do you need to look all the 2 to 10 millions? And so on. Okay, but this one I leave you to think. Do I need to look for all the numbers? Or I can skip all the even numbers? Or I don't need to loop so many times? I'll leave you to think, okay? subspan. So these are the three types of loops. And another for handphone time. Can you get out your handphone? Yes, okay. This time, how many questions? 5 questions. Okay. Ready? Anyone need more time? Okay, so let's start. If I want to do computation, then I'll multiply A times B by adding B A times. Is it okay? A times B means B plus B plus B plus B plus B plus all together A times, right? I want to do that instead of using multiplication. How am I going to code this here? So I input A and B. What is the range? Hey. Correct answer is ooh. Ooh. Why? Why so many people wrong? I want to add B A times, which is the loop that I will actually loop A times. Is 0 to A, right? And then the initial value of the answer is 0. And this one gives you what? This one will actually loops A plus 1 time and plus 1 more A. So the numbers and the result of that is actually B times A plus 2. Okay? And actually, why is this answer wrong? I initiate the number of the answer is A, and now I add A minus 1 time to A. Why is it wrong? This is the horrible type of coding. As in, this code is sometimes right, sometimes wrong. When is the time is right? Yes, when A is positive or actually A is not 0. Okay? But if A is 0, too bad, the code is wrong. Okay? So it is sometimes right, sometimes wrong. So you need to check that. Okay, ready for next question? To print a star n times, I just want to print the star n times, right? What is the expression? This one is easy. Yeah, very simple. I input an n, I want to print it n times. Hey. Okay, this time is good. Most of you got it right. Because I want to n times, the number of times is the difference between the two numbers, right? And there's the only the one that is difference n. Okay, Hui Jie. Okay. If I want to compute the sum of the integer from 1 to n, for example, is n is 4, I want to compute 1 plus 2 plus 3 plus 4. How do I do? Which type of loops do I use? I can only use for loop? I can use only while loop or what? The answer is, oh, good job. most of you knows, okay? It's like the factorial. I can use while loop and for loop. The immediate thing you can think, oh, I can use a for loop, but then you can also use while loop, right? So that's why. Hui Jie. Okay, now a lot of time when you enter a password, you need to have all this complication rule, right? Your password must be more than 12 characters. You must have one pound sign, whatever. Okay, but let me make it simple. If you have a string, I want to make sure at least one of the character is a number. You know, right? Your password must include at least one number. Which types of loops should I use? Of course, you can do all of them, but which one is the best, I would say? Theoretically, you can do anything. Then why is not number two? You say anytime, because my password is any length. But when I talk about that, it means when you enter the loop, you already know how many times. It's when you enter the loop, okay? So that means when you enter the loop, if you have password is n characters, there's n times. But anytime you find a number, you can already exit and say yes. Okay, that go fall into that format. So what you do is you do a for loop, and then you can return anything inside that. Of course, I think the second answer can be correct, but it's not the best answer. Okay. Yeah. Okay. Assume I already given you the prime number. Okay, you just have a prime number function. You can check a number is prime or not. So for example, if I give you 7, you can check it's true. I give you 8, you can check it's false. Okay. Now the question is, I give you another number, any number n. I want you to find what is the smallest prime number that is bigger than n. Okay, for example, if I give you 10, the next prime number is 11. Okay, how do you do that? And which type of loops do you do? Okay. Wow, good job. Most of you got it right, okay? Because you don't know how many number afterwards. Okay, what is the prime number gap? Okay, that is the biggest problem. Okay, how many prime numbers gap between each two prime numbers? That means after 100, what is the next prime number? After 1,000, what is the prime number? And you don't know how many times you need to loop. So you cannot use a for loop anyway. So there is not A or C. So you must use B because you don't know when are you stop. And the stopping condition is when you find a prime number. Okay. Okay, good. Is it Hui Jie? Oh, sing. Who is sing? Okay, later on come to me. Okay, so if you can get 1 and 2 right, probably you already quite mastered the loop, okay? You can know what is the condition and what is the 1n and so on. If you get 3 and 4 right, you can actually already kind of approaching A. You can actually apply the knowledge of this loop to different situation. Okay, so the following thing is about for loop. The main thing is the for loop is you know how many times the while loop is you don't. And remember, I will skip this to tomorrow. Remember we talked about the Monty Hall? The good things, okay? And then you say, oh, the good thing is you can actually use probability theory to prove it. But actually what I do is I write a program. Oh, where's my idle? Yeah. Instead of the code is actually in, I think in the past year's cosmology. I write a code, okay? You can download the code later to have a look. In brief, the code doesn't involve any math. I just generate I just try to play the game 1 million times, whatever. Okay? I try to play the game 1 million times, and each time I randomly generate a door and randomly generate a choice. The only difference is in the code, I will have this if the person switch or don't switch. And then I just play the game 100,000 times and see how many times will the user or the player hit the car if he doesn't switch or switch. Okay, so this one. Yeah, so this is the experiment. After I run 100,000 times, if the player won't change his mind, his number of times that hit the car is this number. And the percentage is 33.1%. Is about 1/3, right? So, but if he switch, he changes his mind, his number of hitting is this. That means 66% is 2/3. So I don't need to know the maths. I just need to run the experiment to tell what is the answer, okay? A lot of time, you can actually do some experiment to find some numbers like that. And also the other one is going to be in your assignments. How do you find pi? 3.14. How do you compute this number? You know how people compute that number? There's one way to compute pi by throwing sausages. You can go and Google it. How to throw sausages to compute the pi. Okay. And before we end, let me give you a poem. This is the love poem for you to give it to your other partner that also knows Python. Okay. What is this poem about? Let's try to interpret it. This poem says, everything I say is true. And you are my everything. And my mind is all stored by you. And I didn't give a conditional statement in my code because my love to you is unconditional. And my love will be trapped in this eternal loops of infinite loop that is forever. And lastly, I didn't put a return because I didn't ask for any. Okay, so yeah. But basically, you learn all these tricks. I hope you can understand this. So we'll try to see whether you. Okay, so that's all for today at this moment. And let's see if there's any question in the poll everywhere. Oh, no today. Oh, I think you're too engaged in that. Nobody asked question. But if you still have a question, please come to see me. Okay. So that's all for today. Thank you. I actually feel like this gets a number 1 in the tutorial instead. Okay, this is actually, you can also read it by yourself because it's actually try to make a game and it just mix up all the loops and conditions we use in this lecture. Thank you.